Hi, I am Anurag Datta, your instructor for today. Today's topic is force on moving charges in a magnetic field. Let's have a look at the topics we'll cover today. To learn about this topic, first, we have to know what is a magnetic field. A magnetic field is a vector field in the neighborhood of a magnet, electric current, or changing electric field in which magnetic forces are observable. To know more about magnetic field and how it is produced, click on the I button. The magnetic force on a free-moving charge, Q, is perpendicular to both the velocity of the charge, V, and the magnetic field, B, with direction given by the right-hand rule. The force is given by the charge times the vector product of velocity and magnetic field. Let's look at that diagrammatically. So, this force on a charged particle produced by its motion through a magnetic field is called the Lorentz force. So we can say that the Lorentz force is the force exerted on a charged particle, Q, moving with velocity, V, through an electric field, E, and magnetic field, B. The entire electromagnetic force, F, on the charged particle is called the Lorentz force, after the Dutch physicist Hendrik A. Lorentz, and is given by the formula F equals QE plus QV cross B, where F equals force, Q is the electric charge, E is the external electric field, V is the velocity, and finally, B is the magnetic field. In terms of the angle theta, between V and B, the magnitude of the force equals QVB sine theta. There is an interesting result of the Lorentz force, which is the motion of a charged particle in a uniform magnetic field. If V is perpendicular to B, that is, with the angle theta between V and B as 90 degrees, the particle will follow a circular trajectory with a radius of r equals mv by qb. The SI unit for magnetic field strength B is called the Tesla, after scientist Nikola Tesla. To determine how the Tesla relates to other SI units, we solve F equals QVB sine theta for B. The other unit for magnetic field is Gauss. 1 Gauss equals 10 to the power minus 4 Tesla. This unit system is often used when talking about small magnetic fields, but it is not the SI unit system. Thus, the Earth's magnetic field is around 0.5 Gauss. There is no magnetic force on static charges. However, there is a magnetic force on moving charges. When all charges are stationary, their electric fields do not affect magnets. But, when charges move, they produce magnetic fields that exert forces on other magnets. When there is relative motion, a connection between electric and magnetic fields emerges and each affects the other. Can magnetic field do work on moving charge? The magnetic force is always perpendicular to velocity, hence it does no work on the charged particle. The kinetic energy of the particle and its speed thus remain constant. The direction of motion is affected, but not the speed. The force experienced by a moving charge will be maximum when its direction is perpendicular to the direction of the magnetic field, and the force experienced by a moving charge will be minimum when its direction is parallel to the direction of the magnetic field. Charged particle accelerators like cyclotrons acts on the principle that particles move in a circular orbit when V and B are at right angles. For each revolution, a carefully timed electric field gives the particles additional kinetic energy, which makes them travel in increasingly larger orbits. When the particles have acquired the desired energy, they are extracted and used in a number of different ways, like studies of subatomic particles, medical treatment of cancer, etc. So, that was all from my end. Hope you all liked the video. Please let us know in the comments section if you have any suggestions. Cheers!
Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. You can check our other website as well. We have features like YouTube Trends, Twitter Trends, Scientific Calculator, and many more other tools. If you like our video, please like, comment, and share. If you have any questions, please comment and we will resolve your query.